Welcome to video number 27, Random Effect Model, Introduction to Panel Data, Part 3. In my previous video, I have discussed fixed effect models, and in this video, I am going to discuss random effect model and when we should use random effect model and when to use fixed effect model. So, when the observed variable of interest are constant for each individual, a fixed effect regression is not an effective tool because such variables cannot be included. I will discuss this in my second part of the video. That, for example, if you are talking about schooling effect for people who have completed their schooling, no, if you monitor them for 2 time periods, 3 time periods, 4 time periods, their schooling will remain same. So schooling effect will not change for those particular individuals over the next 5 years. So that effect will be eliminated. So in such cases and in some other with some other conditions, we should consider random effect model. So random effect model is very effective tool provided 2 conditions are satisfied in panel data. The first condition is that we should have ZP as a random draw, and second, that this random draw, this ZPR, which is basically summarized as alpha I, this alpha I should be independent of XIT. So second assumption is that alpha I must be independent of XIT. Now you have a compound error here, UIT, where alpha epsilon IT are obviously random. If alpha I are random, so UIT may be random. If UIT may be is random, UIT is independent of this. This is only possible if alpha I is independent of X. So 2 conditions: that your ZP is a random draw. Second, alpha I and X all X size are independent of each other. If these 2 conditions are satisfied, we should use random effect model instead of fixed effect model. Why this is the case, what are the merits, we'll discuss in second part of this video. So if this is not the case, it means your alpha I and xi are not, they are correlated with each other, and this will lead to inconsistent bias and inconsistent estimates. So you should use fixed effect model instead of random effect model. Another complication in random effect model is that now you have a compound error term, so you can have autocorrelation across for one individual over time, and that will lead to basically issue in variances, standard errors of the coefficients. So how to overcome this issue? First of all, let's see what happens that you have individual 1, 2, 1 over time period 1, 2, and 3. You have alpha 1, epsilon 1, 1, epsilon 1, 2, epsilon 1, 3. These 3 are independent of each other. But when alpha 1 is added, these become correlated across over time. Same is case for individual 2, same is case for individual 3, and so on. How to overcome this problem? You need to a different estimation technique. And what is that? That is basically you should use feasible generalized least square instead of OLS. That's basically how we estimate random effect models. And as I mentioned, that we should use feasible generalized least squares. I am not going in these techniques and these technical derivations at the moment. I'm trying just to give you an idea that when to use random effect model, what are the conditions of random effect model, when to use fixed effect model. So here in this case, you see that your coefficients, if you use OLS, are different than fixed effect, then random effect. So obviously this makes a big difference. So which technique to use, which model to use, that's important. And in the next slide, we'll choose how to decide whether to use fixed effect or random effect or OLS. So you see, the random effect is in principle more attractive. Why it's more attractive? As I mentioned in the early part, that when you have a variable which is which remains constant over time, that if a variable is not included in fixed effect model, its effect is eliminated. It has to be dropped. Whereas this is not the case in random effect model. So I have given you an example of earning regressed on schooling. Schooling will be eliminated for those individuals who have completed their years of schooling for all coming years. Then second, that you have to estimate n minus 1 dummy variables, least square dummy variables in fixed effect model, whereas this is not the case in random effect model. So you save n degree of freedom by using random effect model. But please keep it in mind that for random effect model, two conditions must be satisfied. First, ZP alpha I is a random draw. Second, alpha I and xit are independent of each other. Then if your assumption, these two assumptions are violated, that alpha I and xit are correlated, or the Z is not a random draw, then you should use fixed effect model. As I mentioned, that first it should be drawn randomly. Secondly, that it should be independent of xit. Now you see, if you are talking about OECD countries, obviously it's not a random draw from 200 countries of the world. Similarly, we have discussed fixed effect model for 48 US states data. Those 48 US states is not a random draw. So in such cases, random effect models cannot be used. So how to test whether alpha, second condition, alpha it and xit are independent of each other? There is a test known as Hausman test. Hausman test or Durban-Gu Hausman test. If it rejects this, that alpha I and xti are not independent of each other, then you again cannot use random effect model. So if this alpha I is not a random draw, or alpha I and xt are not independent of each other, then you should not use this random effect model. You should use fixed effect model. Okay, this is that alpha it are distributed independent of xit. This is the Hausman test. Okay. Next one is that, and it has chi-square distribution. The chi-square distribution, we don't go in that. If and you can use actual number, degree of freedom, and all these technical issues. Now you see, in this case, fixed effect estimates use within group approach, and married men and soon married men coefficients are 0.106, 0.045. Here this model has slightly inflated numbers that may create a suspicion that there is some unobserved heterogeneity. Okay. Now, when we have applied unobserved heterogeneity, means some variables should be part of here, whose effect is captured by this one. So, when we have tested alpha I and xit independent, we got test statistics equal to 306, whereas critical value is 34.5. So Hausman test rejects that alpha I and xit are independently distributed. So we have to think about fixed effect models instead of random effect models. Sometimes this UIT is purely random. If this UIT is purely random, there is no correlation, autocorrelation. So it means you can use, then there is a close match between random effect model and OLS. So in that case, if this is the situation, that when we should consider whether there are unobserved effects, it is possible model has been so well that disturbance term U consists of only the purely random If UI is purely random, then you can use pooled OLS instead of using feasible generalized least square, instead of using random effect model. So Brosh-Pagan test and all that, we don't go in that detail. Let's come to the last diagram, which helps you when to use fixed effect, when to use random effect, when to use OLS. If observations can be described as being random from a given population, then you should try both fixed effect and random effect. If it's not a random draw like 48 US states data, like OECD countries, then simply go to fixed effect model. If this is the case, then again, the first condition is satisfied that it's a random draw. Second condition, that alpha I and xi are independent, then use this Hausman test. If it passes, use, it means if it rejects that there is a null hypothesis, then use fixed effect. If it does not reject, then go again, and then again see that UIT is purely random. If it's purely random, then does test indicate presence of random effects? If yes, use random. If it is purely random, use pooled OLS. I hope this will help you in determining when to use fixed effect model, when to use random effect model, when to use pooled OLS estimation. I'll try to have workshop on this panel data of fixed effect models, the video number 26 and this video number 27, random effect, and I'll show you fixed effect, random effect, and how to apply Hausman test. Thank you for watching. Take care.